Good evening, everybody, and a very, very warm welcome to the Royal Society and to this, which is the fourth in this discussion series called You and AI. My name is Chris Bishop. I'm the Laboratory Director of Microsoft Research in Cambridge. My great pleasure to be the host for this evening's presentation, which I know will be very stimulating and very engaging. As I'm sure you all know, the Royal Society has played a part in some of the most fundamental, some of the most significant, and some of the most life-changing discoveries in scientific history. And Royal Society scientists today continue to make outstanding contributions to science in many important and diverse research areas. In April 2017, the Royal Society launched its landmark report on machine learning. This called for action in a number of key areas over the next 5 to 10 years to create an environment of careful stewardship that can help ensure the benefits of this technology are felt across society. It also called for an informed public debate about the development of machine learning and how its benefits are distributed. The You and AI lecture series builds upon the legacy of that report. It aims to help open up a conversation with leading experts about how AI affects people's daily lives, its implications, and how companies, organizations, and public institutions should respond. Now, in the inaugural lecture in this series back in April, we heard from DeepMind founder Demis Hassabis about the capabilities and the frontiers of AI. Following this, we welcomed 4 world-leading authorities from 4 distinct but very different specialisms to provide an insight into how they currently work with AI and its potential for the future. Then last month, Professor Cynthia Dwork from Harvard University and Microsoft Research opened up the conversation about the fairness and ethics of AI, and that's a topic that we'll continue to explore this evening. This series, which is generously supported by DeepMind, will help develop a public conversation about why machine learning and AI, what they are, how these technologies work, and the ways in which they may affect our lives in the future. So tonight, it's an enormous pleasure to welcome Professor Kate Crawford. Kate is a widely published researcher, academic, author, who has spent the last decade studying the social impacts of large-scale data, machine learning, and artificial intelligence. I'm very proud to say that she's a colleague of mine at Microsoft Research. She's based in our New York laboratory. She's also a distinguished research professor at New York University and a visiting professor at the MIT Media Lab. In 2016, she co-chaired the Obama White House Symposium on the social and economic implications of AI. She's published in academic journals such as Nature, New Media and Society, Information Communication and Society, and has written for the New York Times, Harper's Magazine, and the Washington Post. She has also advised policymakers in the European Union, the United Nations, the Federal Trade Commission, and the City of New York. She's also the co-founder and co-director of the AI Now Institute at New York University, which is a leading university institute dedicated to researching the social implications of artificial intelligence and related technologies in what is very much an interdisciplinary context. So please welcome Professor Kate Crawford.
Hello. Good evening, everyone. It is such an honor to be here. I'd like to say thank you to Chris for that generous introduction, and thank you to the Royal Society for inviting me to be here tonight. And a particular thank you to all of you for turning up. It's great to see so many welcoming faces here in the room and in the overflow room. Hello to you as well. So, as Chris said, I've really been researching the social implications of AI and related technologies for a long while now. But this decade has been a particularly momentous one. It seems to me that we are essentially at a crucial inflection point where we're starting to see all of these technologies move further and further into everyday life. And it's basically a commonplace now to say that AI is touching healthcare and criminal justice and education and finance. But what is less commonly observed is that that is happening at the exact same time as the political road is taking a sharp turn to the authoritarian side. And the combination of these two forces, I think, represents some very difficult issues for the field. So tonight, I want to talk about the relationship between politics, power, and artificial intelligence. How power works in society, how it's centralized, and how AI is amplifying some of those forces. I also want to talk about the role of science, because of course we're here at the Royal Society, in both creating and critiquing this type of power, and what we can do to address some of these darker dimensions. But let me begin with a story. So back in February this year, researchers from the universities of Southern California, UCLA, and Lincoln, Nebraska, presented a paper about predictive policing. They claimed that they'd developed a system that could automatically classify crimes, and in particular, whether or not a crime was gang-related. And they did this by using a whole lot of data that harvested from the LAPD, particularly the data on gang members. Now, as some of you know, this data is notoriously skewed and it's riddled with errors. In the CalGang database, for example, there are 23% of people who've been shown to have no relationship to gangs at all. And in fact, there are dozens of babies listed in CalGang as active gang members. Interesting, yeah, very busy. Further, most people who are added to that database have never been charged, and once you're on it, there's no way to remove your name. Yet the researchers used this list as their definitive ground truth for training their predictive gang member detection system. So people in the audience, when this paper was being presented, started to clue on that this was a bit of a problem. And so people were sort of raising their hands and saying, don't you think there are some dangerous biases in that data that might propagate into your model? And one of the authors just stopped and he replied, well, I'm just an engineer. And it's a curious phrase, just an engineer, because it recurs time and time again in the history of the 20th century. And I want to suggest that we've reached a point in AI development where this separation from responsibility has become the norm, but that we can no longer afford it. Because AI has now moved from being a purely theoretical discipline to one that is being applied at scale. Companies like Axon in the US, for example, right now are claiming that they're using their AI lab to predict future criminal activity and to use data from police body-worn cameras, which right now are everywhere in the US, to tell if somebody has a criminal record immediately, and then to detect the emotions on their face and to take action based on that. So we're at a time in history where our technical papers are very quickly being built into systems that don't just reinforce long-term structural bias, but they're automating it in ways that are both invisible and unaccountable. Now, frankly, this shouldn't be a particularly controversial thing to say. One of the earliest pioneers in AI wrote decades ago that we ran this risk of being so seduced by the potential of AI that we would essentially forget or ignore its deep political ramifications. This is Joseph Weizenbaum. He was the man who invented Eliza back in the 1960s. This was the first chatbot ever, and it was also one of the first programs capable of essentially attempting the Turing test. Now, Eliza was actually very simple. She was just using pattern matching and scripts to try and convince people that they were having a conversation with her. Some of you might actually have engaged with Eliza. Put up your hand if you've ever sort of chatted. Yes, several people. Okay, you remember Eliza. And the amazing magic trick of Eliza was that people thought that she really understood them. They were absolutely convinced that this was an intelligent machine. Well, this frightened Weizenbaum. He saw that as a type of what he called powerful delusional thinking about the power of AI. His concern, above all, was that AI systems would allow engineers to put distance between themselves and the true human cost of the systems they designed. So, for example, a war planner would look at the loss of human life as merely a series of probabilities. So early on, Weizenbaum saw this over-reliance on sort of technical accuracy at the expense of social implications. Well, we've had 60 years and over of AI development, and we still haven't learned that lesson. The field has worshipped at the altar of the technical, prioritizing it over the social and the ethical. And frankly, this is a driving reason why I and my colleagues established the AI Now Institute at NYU. It's prime directive is to study the social and political implications first, rather than always prioritizing the technical. So what I want to convince you of tonight is that these fundamental social challenges are profound and important and urgent, and we need to address them with the same commitment and rigor as improving algorithms and optimizing technical systems. So my talk tonight is going to address 4 key themes with some additional physical humor that we can add in. First of all, I'm going to talk about this thing called AI and what it means. Then I'm going to talk about bias, how it gets into systems, and why there are no easy tech fixes. And then I'm going to talk to you about the big picture, the politics of classification itself, and the political work that AI systems are doing right now. So first of all, what is this thing called AI? Well, it's interesting how often this term is used and how few people actually want to define what it is. Of course, AI is a very hyped term right now, but it has a very long history. It goes all the way back to the Dartmouth Conference in 1956. But I want to suggest tonight that AI is 3 things. It's technical approaches, it's social practices, but it's also industrial infrastructure. So the technical approaches of AI have changed dramatically with the decades, from symbolic logic and expert systems to what is currently in the height of fashion, broadly known as machine learning. Now, even machine learning itself is a constellation of technical approaches, like deep learning and imitation learning and reinforcement learning. But most simply put, we can think of the current state of the art of AI as a grab bag of techniques from statistics and gradient-based optimization algorithms. The fact that we use the word intelligence inside artificial intelligence, I think is something of a trap. In fact, I think I agree with Weizenbaum on this, that sometimes we mistakenly assume that these systems are actually in any way similar to human intelligence. Machine learning approaches right now, to be honest, are very, very far from intelligent, but they are good at detecting patterns, clustering, optimization, and making predictions across vast data sets. So secondly, AI is also social practices. Who works on these systems? Who decides what problems we should prioritize? And how humans will be classified? That powerfully shapes the type of AI systems that we have today just as much as algorithms do. It also matters who's in the room. And sad to say, the AI field is extremely demographically skewed right now. The top 5 tech companies in the world are overwhelmingly male-dominated, and they come from similar socioeconomic and education backgrounds in computer science and engineering. And this creates somewhat of a monoculture, and that shapes the kinds of problems that AI is choosing to address and which populations, ultimately, are best served by those tools. So thirdly, AI is also a massive industrial infrastructure. This here is an exploded map of a single Amazon echo. You might have one in your living room, for example. This was created by Vladan Jola and I. And we made this to essentially just visualize what it takes for you to clap your hands and say, Alexa, what's the weather? What happens, of course, begins all the way over on the left, from the smelting of rare earth minerals and then the refinement and production that takes them all the way into the actual building of these single units. But then we also need to think about the large-scale data centers in places like the American Midwest that are being used to analyze your voice, figure out what the command is, try and send you back the relevant piece of information. That one moment of convenience is calling into being a truly planetary computational network. Now, the resources to build and maintain a network like this are gargantuan. And vanishingly few companies can really do AI at scale like this. So even when you hear that there's this thriving AI startup culture, you should know that they're all, in the main, hosting their systems and buying their compute cycles from the same small cluster of around 6 companies. So AI is a profoundly concentrated industrial infrastructure. So at each one of these layers, the technical, the social, and the infrastructural, AI is rearranging power. And it's about configuring who can do what, with what, and how knowledge itself works. And I think this makes AI an inherently political tool. And essentially that means we all need to give it more ethical weight. One of the real moments where the AI field has been forced to contend with its social implications has been this bias debate. So I'm going to turn to that now. Essentially, it was around, 6 to 7 years ago now that I first started researching and writing papers about these issues of bias and skews in big data. Do you remember big data? Yeah. Well, obviously, it was interesting, actually. Demis in his talk noted that big data was actually more of a problem than a solution. And he's absolutely right. It also had a series of very serious skews and biases built into it. And it has become the raw material of AI, but it's brought all of that baggage with it. So you've likely seen lots of articles like this recently, all about how bias and discrimination is being discovered in AI systems. Everything from women being less likely to be shown high-paying job ads, through to Amazon Prime not delivering to poor neighborhoods, to racial disparities in both policing and education AI systems. And in a way, this shouldn't really surprise us, because machine learning works by discriminating. It detects how your patterns are different to mine, how my geolocation is different to yours, the differences in our social networks, and then uses these particularities, if you will, to make predictions about how to influence us, from what it can try and sell us, what products we might be interested in, to how much your health insurance should cost, to who should get out of jail. All of these systems already exist, and they're trained on data that informs them on how to make those discriminations. But often, that data is very skewed. For example, if you do an image search on CEO, this is what you get. Yeah, notice a few patterns emerging there? It's a lot of white guys in suits. And what's interesting here, of course, is that these images reflect the images that have been gathered from the web and also from stock photography, which is a major thing here. And then AI systems reflect them back to us, and then people click on the top results, and we start to see this powerful feedback loop. Actually, when we sort of ran this test about 6 months ago in the lab, we were really curious who the first female CEO would be. Any thoughts? Who do you think it would be? That would be a reasonable suggestion, yes? In actual fact, CEO Barbie. Yes, she was the first. Not a great look. But actually, this isn't a new problem. Back in 1972, there was a Playboy centerfold by the name of Lenna. A group of computer scientists brought a copy of Playboy into the lab that day and decided to use her centerfold image to test their system. So remember when I was saying that AI is also about social practices and who's in the room and what their interests are? Yeah, that tells you something. She has now become the single most used image in computer science history. You will find her everywhere, from machine learning papers to all sorts of image processing systems. Now, very few people actually know that this sort of foundational image of computer science is actually a frame of porn. She is, in fact, Eve in the Garden of AI. And in some ways, she makes me think that we also have a type of original sin in our technical systems, that we don't think enough about the social context of the data that we use and the tools that we build. And this can come back to haunt us. So how does this just keep happening? Well, to give you a sense of that, I want to open the hood on AI systems and give you a sense of how they're trained. So, for example, this is a benchmark training data set, which is used in machine vision. It's called labeled faces in the wild. And training sets like these are ultimately how we teach AI systems to see the world. We harvest millions of images, and then you train a system to recognize patterns. In other words, they're seeing human culture through the lens of our past. Now, labeled faces in the wild has around 13,000 images, but it also has some notable skews. It's around 78% male and 84% white. So those are the people for whom a system trained on this will work the best. Now, have a guess who the most represented face is. Anyone? Be brave. Who might it be? Oh, yes, you know. Fantastic, we have an expert in the room. And George W. Bush only makes sense when you know that these images came from a prior training set called Faces in the Wild, which was generated by scraping Yahoo News between 2002 and 2004. So it's no wonder that W is everywhere. Because as we know, and this week painfully so, presidents get a disproportionate amount of news attention. My apologies. But it's also a reminder that datasets reflect our social hierarchies and our structures of power. Let's look at another benchmark training data set. This is AVA, and it's made of hundreds of movie clips, and it was designed so that machines could really detect human actions and human gestures, like picking up a glass or sitting in a chair. And they chose movies because it was believed that this would represent lifelike activity. Well, if you browse through a category like playing with children, for example, all you will see is women. All women. Apparently men, you never play with children. Not a thing. But don't worry, you are in there in the kicking a person category. Yeah, that's where you'll find all the dudes. So ultimately, en masse, this could concern us. The cultural lessons that are being learned here may not be the ones that are going to best serve us. And I think it's making the most stereotypical versions of human culture the basis of the systems that are training our future. And this is ultimately creating a standard training set for life, and it's a deeply normative vision. And of course, these bias problems don't just plague images, it's in text as well. The word embedding models that are used in machine learning, in everything from image captioning to automatic translation, are having lots of problems. As several research papers have shown, including some of our colleagues, words like genius and tactical are associated with male, and terms like homemaker and crafts and modeling are associated with female. And those biases also turn up in sentiment analysis. When Google's natural language API was released, if you typed in words like Jew or gay, it was associated with negative sentiment. But if you typed in phrases like I'm straight or even white power, you would get positive sentiment. And the scale of this problem is now being really acknowledged by leaders in industry. In just the last year, we've had Mustafa Suleyman, one of the founders of DeepMind, who's in the room, including the CEO of Microsoft, Satya Nadella, and also John Giandrea at Apple, have all called this a core problem of the field. So we're starting to see a research field crop up on fairness in machine learning. I love this chart by Moritz Hart because you can see that it's gone from just a few of us thinking about this issue to suddenly this moment in 2016 where it's like, uh-oh, we got a real problem. And this surge of interest is, of course, completely justified because machine learning systems are starting to impact millions of people every day. So now we have all these computer scientists working on fairness and bias issues. So can't they just solve this problem with new algorithms and better data? Well, I want to suggest to you that thinking about bias in this narrow way is not going to be enough. In fact, as someone who has been working in this space for quite some time, I'm going to be really honest with you tonight. I'm worried that some of these narrow technical approaches could be making this problem a lot worse. Machine learning researchers are sort of misapplying terms like fairness and discrimination and inclusion, basically just to refer to math, to the statistical performance of a particular predictive model. So in recent research that I've been publishing with my colleagues Solon Barocas, Hannah Wallach, and Aaron Shapiro, we've basically looked at all of the computer science papers to see what the dominant techniques are for addressing bias. So these are three of the big ones. Scrubbing to neutral is very common. The idea here is that you just delete the biased associations. And this is certainly what happened with Google's sentiment tool. As soon as the news stories broke that these somewhat shocking phrases were receiving these kinds of sentiment analyses, they immediately deleted those associations, and now you'll see them as all appearing as neutral. But that doesn't solve the problem, given the many less obvious gender and race biases still remain. And there's an even bigger question we should ask here. Whose idea of neutrality is at work here? Do we assume neutral is just the world as it is today? Does it seem neutral to us? Or do we try to account for the fact that we have a very long and complex history that has actually brought us to this place where many populations have experienced centuries of discrimination? This problem also comes up with the CEO example that I shared with you. If you look now, you'll see that the two big search engines have actually tweaked the results, and you'll see a sprinkling of more diverse faces. But how do you decide who should be represented there? Do you go to demographics? Do you say, okay, what percentage female CEOs do we have? Okay, it's shocking, but let's just stick with that. Or do you try to say, we've got a problem here, let's try and tweak it so that we have the version of society that we would like to see, knowing that these images produce their own feedback loops? Well, whatever you decide as you think about it right now, know that those decisions are ultimately political decisions, but they're rarely acknowledged as that in the industry. Here's another example. There have been a whole lot of papers recently trying to develop a fairer risk assessment algorithm system for the criminal justice system in the US. Now, the technical community, in the main, has just accepted that predictive risk scoring is a good way to reform criminal justice, and they've been focusing on these quite narrow computational approaches to make them more fair, so that populations in different races will be treated the same. But different groups, of course, are not policed or charged in the same way or even treated equally by judges. So treating everyone the same in these systems can actually produce this problem, which is that parity is not justice. And what's worse, machine learning approaches are dependent on metrics, so the sort of subjective issues that a judge might bring to bear all drop out of the system. And finally, there's no due process. Defendants can't query these systems in the way that they would other forms of evidence. So the net result is that some of these ML fair algorithms can actually still be very unfair. Now, frankly, at this point in time, my real concern is that it also shuts down public debate about how these systems work. Where in the sense that people are told, oh, this is purely a technical intervention, it's objective and it's neutral, and then somehow it's seen as outside of the political. This is another version of the just an engineer problem. Hey, it's just engineering, it's not politics. For example, a computer scientist said to me recently, I don't really understand anything about criminal justice, but I know I can make this algorithm more efficient. The question is, when we're working in a racially disparate system, what are we optimizing for? And might we be optimizing forms of injustice? Another really important paper recently was from PhD candidate Joy Bulamwini and one of my colleagues, Timnit Gebru, and they tested 3 face recognition systems. And the results were stark. All of the systems performed significantly better on men, and they all performed worst on dark-skinned women. So how was the study used? How did people respond? Well, all of the tech companies said, we can fix this, we can address it by widening the data set that we're using. So they did that, and we've made considerable improvements. But we might be getting closer to parity in the detection of faces, but it's done by harvesting more and more images of people from minority groups. These are the same groups, of course, who are the most exposed to surveillance, to deportation, and to over-policing. So we just made those people easier to track and easier to surveil. So I think there's a kind of confusion that's emerging here. Equal surveillance is standing in for equality. And we're performing essentially with these tools to make them better in ways when we know that they're actually causing disproportionate harm to marginalized groups. And I'm not sure if you saw this, it was a very big deal in the US recently, but one of the CEOs of the facial recognition companies at Kairos said that he would no longer sell facial recognition to law enforcement because he said, and these are his words, it opens the door to gross misconduct by the morally corrupt. Pretty strong words from a CEO. But right now, we don't really have any regulation against these tools. So as Cynthia Dwork said earlier in this series, fairness is a very hard problem. And at the moment, the attempts to eradicate bias are very narrow. And what's worse, we're seeing the creation of a subfield of computer science where people are only trained to think about algorithmic accuracy and performance, but they're also having to intervene in our most sensitive social institutions. Personally, I think we need to increase the safeguards around things like facial recognition, predictive policing, and all of these forms of criminal risk assessment. Because frankly, optimizing unjust systems can cause more harm. We also need to look at this broader context of how a tool is being used and by whom. The little heuristic that I suggest to people is this. When you're working on a system, does your technical approach put more power into the hands of the powerful? If so, you might be deepening the problems of inequality. So right now, we have this dominant approach to bias, which is that it's a bug and not a feature, and we can just remove it. But what if there's actually something deeper going on? Classification and clustering are at the heart of what it means to be doing machine learning today, whether it's identifying a person's gender or race, or assessing their resume, or giving them a risk score. What if these things, by the very nature of classifying a person, is introducing a deeper harm than just bias? So to understand the danger of this, I think we have to go back into the history of scientific classification. And I want to take you back to this guy in the 17th century. He was, in fact, one of the founders of this institution, the Royal Society. This is John Wilkins. He was an English scientist and clergyman, and he was fascinated with classification. He, in fact, developed a whole new language that he said could classify the universe into 40 categories. In some ways, this actually reminds me of the early approaches of symbolic logic in AI, although weirdly, no one seems to have claimed this system from 1688 as being an AI system, but I think there's something in it. A century later, the focus of classification had zoomed in from the universe to the human face. And we start to see the emergence of these pseudosciences of phrenology and physiognomy as ways to classify people based on everything from their face to their skull to their nose shape. Now, physical characteristics were being used to classify people from everything about their intelligence to their criminality. Of course, the most damning assessments were reserved for women and people of color. It was indeed a classificatory system that really served the people who were already in power. But large-scale human classification doesn't really accelerate until 1880, where a young man who currently was working at the US Census Bureau called Herman Hollerith was watching a train conductor stamp tickets on a train. And he thought, I could design a punch card system for tracking human characteristics. And I'm sorry, but this is where I have to break Godwin's law and mention the Nazis. Because, of course, it was the German government who bought Hollerith machines en masse from IBM in the 1930s, and they used them extensively to do massive racial registries of the population, marking out everybody who was Jewish or Roma and other ethnic groups. Frankly, they couldn't have done what they did without the scaling power of the Hollerith machines to classify us into the sort of us and them categories. But now we're starting to see physiognomy and phrenology get a rerun in AI research. In 2016, some of you might have seen this paper, Wu and Zhang published in a machine learning conference, and they claimed that they could predict if somebody was going to be a criminal based on nothing more than a photo of their face. They claimed that this system was free of bias, even though it was just trained on government images of criminals, which is itself obviously a very skewed set. This again seems to me much more like encoding bias in a way that's serving vested interests. Imagine if an autocrat decided to use a system like this to simply just arrest people based on a photo of their face with no accountability or due process. Which brings me to one of the most troubling examples. Michael Kaczynski, the researcher whose work was behind Cambridge Analytica's early methods, released a paper around 18 months ago, colloquially known as the AI Gaydar paper. He essentially trained a neural net to detect facial features that would allow you to predict someone's sexual orientation just from a photo. Now, this paper, I would suggest, has deep methodological and ethical problems, particularly when you consider that being gay is still criminalized in over 78 countries, some of which apply the death penalty. But I'd actually like to make a deeper point tonight. Machine learning as a field is making a conceptual error when we try to classify somebody's race or gender or sexual identity based on their face. It's this confusion of categories to treat these sort of fluid, relational, social ways of being as though they are fixed objects, like a cat or a chair. And I think it can pose real classificatory harms. Now, Kaczynski justified this paper by saying that it's really important to show people that this can be done with off-the-shelf machine learning tools. But I would pose to you the opposite suggestion, that we have an ethical obligation to not do things that are scientifically questionable, that could cause serious harm, and that could further marginalize groups. Just because it can be engineered doesn't mean that it should be. So these claims of predicting whether somebody is gay or a criminal are being made at this time of rising political populism. And I think there are many people who would like to deploy unaccountable systems of power and control. As the leading British intellectual Stuart Hall once said, systems of classification are themselves objects of power. So machine learning, I think, now has a fundamental issue, that we're classifying people based on their race and identity and character and their criminality just from their face. That, to me, seems like repeating the errors of history, of phrenology and physiognomy, and then putting those tools into the hands of the powerful. We have an ethical obligation to learn the lessons of the past. So, what is the political context for AI today? Well, of course, if we just take the narrow sense of the political as governmental politics, we've got plenty of evidence about how technical systems are changing democracy, be it from the outside, with companies like Cambridge Analytica and the many others like them, to being built into the business of government itself. For example, ICE, the Immigration and Customs Enforcement Agency in the US, has been using an algorithmic risk classification system at the border to determine whether an immigrant should be released. Now, last year, ICE decided to change this system so that it recommends detention in 100% of cases. It is a predictive tool that only has one answer. It also has been reported that ICE agents went into those databases and manually deleted the numbers that identified which children belonged to which parents, just as they were separating families into the detention camps. Which reminds us that even a set of well-meaning tools can be manipulated to terrible ends. And now ICE has commissioned something like this, a new machine learning platform to handle no less than 10,000 users simultaneously accessing the records of millions of people. So how does fairness and machine learning work here? Optimizing an algorithm for parity or making sure that dark-skinned people are as easily recognized as white-skinned people is not going to help us. Rather, I think we're facing some fundamental questions of human rights and due process and accountability. What rights, for example, would an asylum seeker have against a system like this? Well, this basically makes me think of one of the great philosophers of power, Hannah Arendt. I had the great privilege of visiting her personal archives recently, and it included all of her handwritten manuscripts, and you can see all of the scrawls with her notes and edits. This is an example of it right here. And in these pages, she observes that the questions that most haunted her generation after the Nuremberg trials were these ones. How did it happen? How could it have happened? And how did we let it happen? She observed that the only thing that held back the totalitarians of the 20th century was that their technology sucked. They had things like lie detectors that were slow and basically useless most of the time. And then back in 1968, she eerily predicts something very, very similar to the policing systems and border control systems that I've shown you tonight. She wrote this: "The police dream that a gigantic map on the office wall should suffice at any moment to establish who is related to whom and in what degree of intimacy. This dream is not unrealizable, although its technical execution is difficult. If this map really did exist, not even memory would stand in the way of the totalitarian claim to domination. Such a map might make it possible to obliterate people without any traces, as if they had never existed at all." Frankly, I can't think of a more evocative description of technology-driven deportation and disappearance. So what are we going to do about this? Well, I think AI may present some very real social challenges, but scientific communities like the one in this room have faced these challenges before. Nuclear energy, genetic engineering, the list goes on. I think research has a real role to play here, and I think one of the biggest challenges of the next decade is going to be these social implications of AI. We also need to contend with something that I think another speaker in this series will talk to you about, Joseph Stiglitz, that AI has the potential to rapidly accelerate wealth inequality. It gives very powerful and actionable information to the very few. So if AI is going to play this role in our social systems, I think it needs to be guided by research that will consider both the positive and the negative dimensions and how they're being unevenly distributed. So this is the reason why we founded the AI Now Institute along with Meredith Whittaker, as a center to just focus on these social implications. But we're doing it in an interdisciplinary way. We're collaborating with computer scientists and engineers and lawyers and people across multiple fields, because I think that's what it's going to take to really understand how these systems work. Secondly, I think ethics is a really important part of what's needed here. And we've certainly seen several of the AI companies release ethics codes recently. And to circle back to Joseph Weizenbaum, he said that the principle of one's responsibilities should be commensurate with the scale and the effects of your actions. That means that, in his words, engineers have far greater responsibility than ordinary individuals because their work extends not just to millions of people today, but also to future generations. So I think we should applaud the people who are currently developing stronger ethical guidelines for AI. But I also want to caution tonight that ethics can very easily be captured by a set of well-meaning but ultimately ineffective phrases unless they're secured to clear and publicly accountable forms of governance. Ultimately, without public oversight, real governance and ongoing monitoring, AI ethics codes, I think, risk becoming a mask that is worn over the face of unaccountable power. So we need rigorous forms of industry and research ethics that are combined with real accountability. But I'd like to end tonight on the biggest thing that I think that we could all do together. Because right now, I think we're plagued with a sense of technical inevitability, that sense that AI is basically unstoppable and all we can do is tweak the edges. We can try to remove some bias here and there, we can create better privacy guidelines, or we can write ethics codes. But these, I think, are always partial responses and very incomplete. What if we looked at this from the other direction and actually reversed this arrow and asked, what kind of world do we want? And how can technologies serve that vision rather than driving it? I think that's the society-wide conversation that we really need to have. Because the decisions that we're making today are going to matter. It's worth remembering that back in the 1940s, when everything looked hopeless during the war, there was an engineer and general controller of occupied France by the name of Renee Camile. And he did a very curious thing. He was responsible for the Holorinth machines in France and making sure that they were categorizing the population. But he decided to sabotage them, and he reprogrammed them so that they could never punch information into the 11th column of the punch card, which is where people would record Jewish identity. And in that one action, he saved countless thousands of lives. This is basically the opposite of saying I'm just an engineer. This is using engineering power to put ethics into action. So if all AI is political, then how it is engineered is an issue that's going to concern us all. And I think this is the critical time for the broader scientific community and the community at large to remember these lessons of power and classification from the last century. Because as AI systems play an even bigger role in our day-to-day lives and in shaping our world, we want to make sure that that's a place that we want to live. Thank you.
Well, thank you very much, Kate. As expected, that was a superb, extremely thought-provoking talk. I know there are going to be lots of questions. This evening we have a packed room, but also downstairs we have an overflow room, and I know that's also packed to capacity. And we're also going to try and take questions from the overflow room via a text system that we hope will work this evening. Before I do open it up, though, I'm going to take the liberty of asking the first question and really sort of picking up on your final point there. I think most people would agree that we live in a world today that itself is far from perfect, it's rife with bias. And clearly there are dangers that you've highlighted, that the power of machine learning could take those biases and amplify them and take them to a very dark place. What about the more optimistic scenario, the power of technology to remove bias and take us, not just avoid the catastrophe, but actually take us to a very good place? Can you comment on that?
Absolutely. I mean, I think many of the examples that I used tonight are really just coming from this early field of fairness and machine learning. But I'm going to be honest about my concern. It's very real that if we keep this conversation just within the technical community, we are not talking to the right people. We're certainly not including an interdisciplinary space, but more importantly, we're not including the people who are being affected by these systems. And so I actually think we have a much greater responsibility to look at how systems work, look at their structural history, and then think about what they should be looking like in future. There's a really good example of this in the US at the moment. So there's this huge debate around how do we reform the criminal justice system. And there's been this weird sort of slippage in the argument where people are like, oh, look, we've got predictive risk algorithms. Let's just use those, and that will solve the issue of cash bail, for example. All of the other research that's been going for 30 years has shown that some really simple things would actually really address some of these questions. For example, for people who don't turn up to their bail hearings, there's been really good studies that show if you get cars to people or if you give them childcare, they will be able to show up. But instead, we've skipped these more complex social responses to go straight to the technocratic ones. And I think that can be a real mistake, because in the end, what you've done is you've said to people, well, the criminal justice system will be fixed by technology. And then people feel quite off-put by that. It's like, oh, well, I can't see how that works. Certainly the judge can't see how it works. Certainly the defendants can't see how it works. So I think we come to a sort of an impasse very quickly if we just say, oh, all of these problems of bias, let's let the computer scientists figure it out.
Right. I think the Royal Society really should be commended here for not only this lecture series, but actually many, many activities which are concerned with public engagement, and particularly in AI and machine learning, where it's being very, very proactive. So I'm delighted to see this public debate and engagement. Let's open it up now to questions. What we thought we would do is maybe sort of take a couple at once. So we'll start with one there.
Hi, thanks very much. I work at a big tech company called ThoughtWorks, and we've been trying to have this conversation, and we're calling our little campaign Building an Equitable Tech Future. My question is, what do you think tech companies can be doing to engage with these issues? Should we be trying to speak to folks outside the tech community, like the people most impacted, which is what we're trying to do? We're trying to create some sort of ethical framework and the conversation, but what can tech companies be doing to proactively engage with this, please? Thank you.
Great question. Well, let's just say it's been a really interesting year for tech companies, hasn't it? I mean, we've seen some extraordinary shifts happening in terms of people inside tech companies really rising up and saying, we are not going to work on tools that we think cause forms of social harm. I mean, at Google, there was a petition that over 4,000 engineers signed to say that they didn't want to work on an object recognition system for drone killing, for example. I mean, this is new. We're sort of really seeing, I think, a very new set of conversations emerge within the companies. And that's certainly where these sort of new ethics codes are coming from. But I don't think that's enough. I think we do have to include the public more broadly. I think we do have to think about what those governance mechanisms are, because it's very easy just to have a set of ethical principles that sort of sit somewhere in a drawer and have no real integration into how a system is being used or deployed or even measuring. I mean, tech companies are very, very large. I mean, from the image that I showed you today, they're sprawling. Sometimes the right hand doesn't know what the left hand is doing. And so I think we have to think much more deeply about what those governance mechanisms will be. And I'm actually quite inspired to think about how we do that. And certainly I know that ThoughtWorks is sort of one of the spaces where those conversations are happening. So thank you for doing that.
Who's next? Yes, the front row. John, just wait for the microphone just so we can capture the...
I'm talking about I want to refer to your points you made about the active gang members and how the LAPD keeps a record of these people. You mentioned that about 23% of it is incorrect.
23% of people have not been shown to have a clear
active,
association.
Right.
Yeah.
And it also included babies.
Yeah.
Now, the 23% I can understand, given the inefficiency and the lack of professionalism in an organization like the LAPD. That does not surprise me. What does surprise me is the fact that they have got babies in there.
Yes.
Now, I'm not a technical person, I'm an accountant, right? But I do understand that the first bit of data you will have about any person is the date of birth.
Yeah.
And in some cases, they might get the date of birth wrong, so the baby is in there.
Yeah.
But how about the rest?
And it's not just a few babies. They have 42 babies when this data set was actually audited. So, I mean, it shows you how easily errors can propagate. And certainly in the case of gang databases, the techniques have been very much based on social networks. So it's really, who do you know? And so people are guilty by association. It is kind of extraordinary that you're guilty now by genetics, and I think in that case it's probably just a straight up error. But either way, it reminds me that it's this combination of biases from an institution over time, also just with straight up technical errors, sometimes with bad system design, and we basically implement a system that we really don't understand how it's working. And this is happening time and time again. I mean, my interest is in the next phase in machine learning. How do we start thinking about things like pre-release trials? How do we think downstream to think about the long-term effects before you're testing it on a live population? I know this is something that some of the companies are really thinking about now, because at the moment, it's really much more of an experimental mindset, and I think we can do better than that.
Right.
Should we just take a...
There's another question just over here.
Sorry,
Can I
well,
just make one comment?
very quick.
We have a few.
It just comes
Yeah.
down to
Yeah.
unaccountable power. Isn't
Indeed.
It?
Well, it's an
And
issue.
That applies across the whole spectrum, whether it's AI or anything else. Thank you.
Just... Yeah.
So you alluded to, but you didn't name them, Asilomar and the pugwash movements, which were the DNA avoiding splicing, which could possibly lead to everyone dying of cancer in a week, and pugwash was the nuclear physicist refusing to work on weapons. But they came from the community themselves very early on.
Yes.
And so how is it we are failing in the community of tech people, because those were tech people too?
Yeah.
What is wrong with us?
Yeah. That's a really good question. I actually don't think there is anything wrong, particularly with what's happening with the technical community, but I do think we've been immunized from these discussions about the social implications and ethics of these tools, partly because the shift in the numbers of people being affected has really just happened in the last, depending how you count, 6 to 10 years. I mean, this is a very, very recent turn. So, I mean, obviously we've had the Asilomar principles on ethics. We've had, I think, in fact, the ACM, the association, the leading association for computer science, is about to release their ethical principles this week. The last time they updated them was 1992, which was before the web as we know it today. So you can imagine how much has changed in terms of thinking about the ethics of computer science. So I think there's some catching up to do. But I want us to go a step further than that. I want us to go a step beyond just coming up with principles. I think we have to think about the cultures, the social practices inside these companies, which really haven't been fostering caution and thinking about social implications. It's been the opposite. It's been move fast and break things, right? And so that has, I think, also been a real sort of cultural abrogating factor to sort of keep ethics at bay. And I think we really have to do better now.
Great. So we have a question from the overflow room.
Yeah, so there's a question from downstairs, which is, actually we've got 3 questions, so I'm going to give you all of them,
Great.
and then you can answer all 3 at one time. So first one is, what can academics and researchers in industry do to strengthen the research capacity of low-income countries around the world?
Oh, yeah.
There's no current regulation and we need more safeguards. How and specifically can or should this be regulated? By states, by businesses, by somebody else? And finally, do we need a version of Asimov's 3 laws of robotics?
Good to see Asimov getting another run. So they're 3 really good questions. I think the first one around how do we actually start to reverse this concentration of power to the sort of the wealthiest countries and the most powerful countries is going to be a really big one. Because at the moment, of course, there are really very few countries who are really developing AI systems. We could talk about the US, we can talk about China, we can talk a little bit in the UK, we can talk a little bit about what's happening in Russia, but ultimately the rest of the world is being treated as a client state. So the geopolitics of the development of AI is going to be key, and how we start to include people from countries that don't have the resources to be developing these planetary infrastructures is going to be seriously important. And I know, again, there are some early programs to try and think about this, but certainly we're seeing some concern from the EU in terms of what's happening. We've seen France and Spain both release AI reports as ways to try and keep talent in their own countries. And we're really seeing the sort of the zombie return of the nation state as a way to try and regulate these forces of AI, which is a way to respond to the second question. And then finally, I think we're going to need a lot more than just 3 principles. Certainly, I mean, as Chris knows, who's doing work in all sorts of domains like healthcare, we almost have to think in silos. You know, what do you need in the context of health? What do you need in the context of, criminal justice? What do you need in the context of education? What do you need in the context of finance? All of these domains currently have forms of regulation, but they haven't really kept up with what's going on now. So how do we really work in those domains to make them sort of safe, secure, and ethical? That's more the way that I think we can start to address those issues.
Great. Question
over here. Hi.
Yeah.
Hi there. Excuse me. I work for a company called Methods, and we do a lot of digital transformation work with government primarily. So we're big kind of government and tech nerds. And we do a lot of work looking at how do we enhance government services by accessing kind of different technology capabilities. And thinking specifically about like AI capabilities, what is the kind of, sorry, I've written something down. Where is the line where government needs to build its own AI capabilities versus buying it off the shelf or something in the middle?
Oh, this is a really tough one. You put me right in the weeds, thank you. Look, the reason why this is really interesting right now is that there is a huge race for talent. I'm not sure if you've all been following the stories, but I mean, basically engineering talent right now is commanding just vast, like basketballer level salaries or soccer player salaries, really, and it's this extraordinary rush to the degree now we're really seeing pressure on universities and professors and their students being hired away. I mean, we've really got a problem now in terms of the sort of giant gravitational force that's pulling all of the talent into the big 5 or 5 to 7, depending how you count. So governments have a real problem. The first problem is, how do you pay people when they're being signed away for these giant checks? The second problem is, how do you create and foster a research environment where people can do their best work? And this is something where I think governments really can offer something different. And perhaps that could also be new spaces for diversity, and they can actually teach us an industry a trick or two there would be really helpful. But I'm not going to be overly optimistic with you. I think that's going to be actually a really difficult problem, and you're really moving against an enormous amount of industry energy, which is focused on soaking up all of that talent.
Great question. One in the front here? Oh, you're next. Yeah.
Hi, thank you so much for that. My name's Lisa and I'm working as an associate lecturer at Goldsmiths College, and there's a lot of talk about engaging the public and getting them more engaged in these debates and getting more of the public's opinion involved in the creation of AI and the deployments and etc. But do you know of any successful public programs that have done this really well? So I know Mozilla is doing some really good things with some of the work that they're doing and the art fund that they've set up. But just, do you know of anything else that's happening? Not necessarily in the US or the UK, but anywhere, literally.
Yes, yeah, I do. I mean, I actually think this is an area where I'm really excited and optimistic as well. I mean, at the AI Now Institute, we sort of collaborate directly with the ACLU. They were one of our founding partners, and the NAACP Legal Defense Fund, and also the Leadership Council, who've been doing sort of extraordinary work thinking about sort of civil rights, civil liberties in the US context. And that is very much about getting the voices of affected communities into the room to think about how research should work. But that's research. And the other question is, how does industry do that? And frankly, industry just doesn't have the history of doing a lot of that sort of work. So I think there's an enormous amount of responsibility that's being put on both sort of the NGO sector, but also on research institutes to try and do that work. And I think we really have to lead by example, because there isn't a great set of stories you can immediately turn to, but there are a lot of what I would say more ethnographic studies that are trying to do that work. So I think it can be done, but as you would know, I mean, that sort of community work is slow. It's not quick, and it shouldn't be people just coming in and extracting information and disappearing. It has to come from the communities themselves. So how those relationships build up over time, I think has to be done in a very sort of authentic and long-term way, but that's how we'll get there.
We're very fast running out of time, but I did promise somebody here who'd have a question, so I think yours will need to be the final question. So no pressure.
Hi, I was wondering, you mentioned the question of how do we decide what the neutrality point is? I was wondering what your opinion on that is and how we might go about answering that question.
Oh, yes. I love that you're ending on, again, a super tricky one. My feeling around this question is that at the moment, we aren't having enough conversations about what neutrality looks like. It's just something that's happening in the tweaking of vast technical systems that for each one of you are sort of personalized to you. So you don't even really necessarily see how the whole beast is working, you're just seeing part of it. And the more that we move into sort of deep learning techniques, even engineers don't understand how a system is producing the results that it's producing. So there are some real issues here around sort of knowledge around how things work. So what that means is that when we talk about neutrality or sort of erasing bias, I think we've got a real problem on our hands in that we don't even have the skills of having this conversation of saying, well, actually, that's a political decision to remove these things or to add these things in. So that's really part of my interest tonight, is to really start reframing this conversation away from AI purely being a set of technical neutral decisions to really being a profoundly political and social sets of decisions. And the way that I think the only responsible way to really start doing that at scale is to, first of all, start making it clear how those decisions are being made, share it with the public, make it part of the discussion, but also really look to the work where people are saying, oh, if you change it in these ways, the following things will happen. There's sort of a disconnect right now between sort of the more social researchers, shall we say, from the human sciences and the technical sciences. So there's various things we can do, but again, I think this is going to be one of the hardest and most controversial problems.
This is so interesting and engaging. There was somebody who had their hand up here who was very keen. Yes, we'll take just one extra question. I hate to wrap it up.
Thank you so much, Professor Crawford, for making the link between power structures and classifications. You suggested that John Wilkins actually started the trend.
No. We can take the trend all the way back to Aristotle and further. I just like John because, this is his house. We're in the house of Wilkins.
Fantastic. So Chris Dixon of Andreessen Horowitz had written an article which was how Aristotle created the computer. And he talks about logic and some of the challenges within logic and language structures. Mm-hmm. And then subsequent to that, Stephen Cave of Cambridge University wrote the article, A Dark History of Intelligence.
Yes, great article.
In which he talks about essentially Aristotle's dualisms being non-value neutral. Mm-hmm. In other words, assigning male or female, intelligent or stupid. Now, if we fast forward to present day, we actually see the implementation of those dualism mechanisms in swipe left, swipe right, in thumbs up, thumbs down, and also in tools such as implicit associations test. Yeah. So my question would be, what's the best way to encourage engineers to pretty much, overhaul that entire dualistic mechanism in all of UX.
All right, guys, we got 5 minutes. Let's do it together. Well, let me tell you a good story first, and then we'll talk about the complexity. There have been changes to these dualistic systems. Back in 2013, I think it was, on Facebook, you could only be one of two genders. You could be male or you could be female. 2 years later, after the Indian High Court decision that everybody has a right to sort of choose their gender identity, they have 72 categories. So, you might say that's a pretty extraordinary shift towards exactly what you're talking about, this sort of move away from sort of binarization. However, it's still a pretty arbitrary number. And you could have done a lot of different things and just coming up with a drop-down menu of 72. You could come up with a free text field. You could have no gender at all. And these questions, these design, these UX decisions actually have profound on-running impacts in terms of the populations. What I'm more worried about now, though, is these systems that are automatically doing classifications. And I just came from a conference where papers were being given about, oh, look, we can easily classify your race by the width of your nose bridge and the size of your lips. And I'm like, wow, this takes us right back to physiognomy. This is exactly what was being done. And the next step, of course, in physiognomy was saying, you have large lips and curly hair, you're probably less intelligent. So those histories, those physiognomic and phrenological histories, are deeply connected to how we do this kind of classification. And I'm really worried that what we're seeing right now is this sort of rise of scientific racism in Silicon Valley. In the actual companies that are designing these systems, we're seeing the return to this type of race realism, I believe they're calling it. So, that terrifies me. And I think that's why, tonight I really wanted to say we need to talk about this. We need to talk about these studies. So we're trying to sort of automatically predict criminality or gayness or race. Race is itself a social and cultural construct. We're acting as though it's this sort of clear biological reality. It's simply not. And we have 60 years of critical race studies to show us that. But it's not reaching the machine learning community. So again, this crucial need for interdisciplinary conversations, and I think some very real public conversations about how we feel about being classified by those systems. But thank you for the question.
thank you very much, Kate. That was a tremendous, and not only an extremely stimulating and thought-provoking lecture, but clearly scratching the surface of an incredibly important domain. I would classify myself as an optimist and an enthusiast around the technology. As you mentioned, one of the areas I'm very interested in is the application of machine learning in healthcare. And I do believe that the potential in healthcare and many other domains to bring societal benefit is absolutely enormous. And one of the dangers that I see for machine learning and for AI is that if we don't have a properly informed and rational public debate about these very important, very thorny issues, we may end up in a world rather like we ended up with genetically modified foods and making decisions on basis other than rational and informed debate. And I think that carries a very real risk that we'll throw the baby out with the bathwater. We'll fail to achieve the amazing societal benefits that this technology can bring. So I think events such as this evening, I think are incredibly important in having that debate and getting these very difficult, very thorny issues out into the public so that we can all participate, because you're right, it's not a problem for just engineers or researchers, it needs everybody to participate. So really delighted that you could join us this evening. So a very big thank you to you. A very big thank you to everybody who's participated and joined us this evening. An event like this evening is completely meaningless without you. The fact that you've taken time to come here and join in the discussion is absolutely central. So a big thank you to all of you here, to all of you in the very busy overflow room downstairs, anybody watching online and who will watch the recording, a big thank you to all of you. And the next event in this series will take place here in the Royal Society on the 11th of September. And we'll welcome the renowned economist and Nobel Prize winner, Professor Joseph Stiglitz, who's going to talk about AI in the workplace. I do encourage you all to come and participate in that event as well. I'm sure that will also be extremely stimulating. But finally, let me finish by just inviting all of you to join me in thanking Kate for a superb evening.